everyone, so we're going to check your cool down questions for Chapter 8. The first few questions are more of a short answer style, just to check your understanding, and then we do have some do the math type problems. As we go out through the semester, you will see more and more problems where you are actually solving, but I wanted you to get in the habit of it now. So here we go. Question 1, what is the meaning of the equal sign? You should have something like the words the same as. So remember, our equal sign doesn't tell us to do anything. It just tells us that this side is the same as that side. When I look over at question number 2, the meaning of subtraction, now that one does tell us to do something. There's two parts to that. You might have said something like it means to take away, which is true, but there's another way of thinking about it in that how far apart are those numbers, or what is the difference between those numbers? And when students get that understanding of how far apart are the numbers, they often have a better understanding of subtraction. Moving on to number 3, the problem types and structures for addition, and question number 4, the problem types and structures for subtraction. These two kind of go together. You're going to see that they have 2 over here for addition, 2 for subtraction, although we know that those functions are inverses of each other. So I can use subtraction to solve perhaps a missing addend problem, and I can use addition to find subtraction to compare. So let's look at the ones that we said were addition, joining, so adding 2, and then another situation for addition is a part-part whole, so taking 2 pieces and putting them together to make a whole. When we look over at subtraction, the ones that we sorted out as subtraction are usually taking from. And then also another subtraction situation that students often struggle with is comparing. So how much more does one have than the other, or how many fewer? Those are all subtraction situations. You might solve them with addition, but they are subtraction structures. Moving on to our math questions here. Number 5. The area model. So this is a visual model that you might have seen in the visuals in your text. So let's take a look at it. So I've got large pieces here and I've got smaller pieces. So I'm going to take these numbers, 20 and 8, and then 30 and 2, and use them as my dimensions for this rectangle. So I've got 20 by 30 in this piece here. And then this piece becomes an 8 by 30 rectangle. Then this piece we have a 2 by 20 rectangle and a 2 by 8 rectangle. You can see these aren't drawn to scale, but using the place value helps us understand them in a way that is a little bit more representational than the abstract of just using the numbers in the equation. So now we're going to find the area of each of these pieces by multiplying. So we'll start out by 20 times 30. Well, I know that 2 times 3 is 6. I know that 20 times 3 is 60. So 20 times 30 is going to be 600. And then down here we've got 20 times 2, that's 40. And for this piece, 30 times 8, well, I know 3 times 8 is 24. So 30 times 8 is 240. And then down at the bottom, we're going to use 8 times 2. So now that I've got those pieces, I need to add them up together to find my total. So I'm going to just quickly do that here. Paying attention to my place value as I add. And I got 896 using that model. We can try again on problem number 6 here. Again, I'm going to use 40 up here because there are no ones, so that's why there's no window panes over on this side. But we can see 30 and 7 down here. So 40 times 30 would be 1,200. And then 40 times 7 would be 280. And in order to get my final answer, I'm going to add those up. No regrouping necessary here. 1,480 should be our answer. Moving on to number 7. 7 was another meaning, another word answer. And so I really just took a snip from our slides earlier, and the meaning of division has two parts here. So we might say, if we have A divided by B, we might ask how many of B are in A. So how many of B could I fit into A? Or I could say that I'm going to take A and split it up into B number of groups. So those are the two different ways to explain the meaning of division. And really, they can be used interchangeably. You're going to find them in problems with those different contexts. But also, you're going to find that if you're just dealing with an equation you're trying to solve, perhaps one or the other of those explanations is better at helping you find a quick strategy to solve. So students should know both of those. Moving on to the last problem, number 8, we're going to turn this into a number line problem. So 10 divided by 2 might be repeated subtraction. I'm going to use how many B are in A. I'm going to use that definition to help me. It's not the only way to solve, but this is just one way. So if I wanted to know that, I could maybe start at 0 and go 2, another 2, another 2, and repeatedly finding those groups and putting them in. So then I can count up my groups, 1, 2, 3, 4, 5, and my answer is 5. There were 5 groups of 2 hiding in 10. So that's just one way that you could use the number line to solve that division problem. We're going to be examining these strategies much more closely in the upcoming weeks. So continue to practice problems like these, and I will hear from you later.